So I want to thank you all for being here, both in person and online. Tonight's talk is sugar, stress, and diabetes. So what I'm going to do, if you're okay with this one's going to be pretty heavy on data. Are you guys okay with that? Because it's not going to be an easy one. I'm going to go pretty depth in it, but I'm going to show you things that you can take that will help you. Simplistically, I'm going to tell you products that you can take that will help you make insulin work better, products that you can take that will actually help you absorb insulin receptors work better. So with that being said, what we're going to be talking about is glucose, blood sugars, all those different things. And what we need to understand here is that what is normal and then what is abnormal or what isn't right. And so what we're going to look at first is what is normal, what's supposed to happen. And then we're going to talk about where the problems can happen. And we'll look at different things. There's really 2 or 3 ways that you can go after it and help people. But understanding normal is really, really important before we try to understand how to fix the problem. So what we're going to look at is
type of surgery is it?
How the cell is going to absorb sugar and how that's going to happen. So first off, we're going to eat food. Then that food is going to be absorbed. So you got to chew the food. There's enzymes in your mouth that will actually break down the food. Then it has to go into your stomach. If you have a stomach problem, you will not digest protein. If your stomach is not acidic enough, you will not digest protein. I'll put it a different way. If you get ulcers or need to take antacids, you will not digest protein. Protein digestion happens in the stomach. Then the food is going to be digested and it's going to come down into the small intestine. In the small intestine, your body is going to release bile to absorb fat. And it's also going to release digestive enzymes from the pancreas to absorb sugars. All of this has to work correctly before it gets into the small intestine so you can actually absorb the sugar. So all of that stuff has to happen. We're doing good so far? Then, if your body's working correctly, I told you it's going to be a lot of data today. If your body's working correctly, the nutrients is absorbed in. So the proteins, the fats, and the carbs are all broken down, and then they're absorbed into the system. When they get broken down, they're broken down into glucose. They're broken down into the sugar that your body's going to absorb. So fat breaks down into glucose. That'll go through a thing called the Krebs cycle, specifically the citric acid cycle. Or no, the uric acid cycle, sorry. The citric acid is protein and carbs. Then the carbohydrates will break down and the protein will as well. But they all have sugar backbones, so they're all going to be broken down eventually into glucose for energy, or protein can be used for rebuilding blocks as well. And the fat can be for rebuilding blocks. Let's just talk about the sugar. So we eat food, and then our blood sugar is supposed to go up. So our blood sugar goes up. Then what is supposed to happen is when the blood sugar goes up, so we're going to make the blood sugar, we'll make it these little dots. Then you're going to have a cell. And on the cell, there are little receptors. And these receptors are for insulin. So what happens is your blood sugar goes up, and then your body's really smart. It has receptors in the brainstem that tells you if the blood sugar is too high or too low. And when that happens, it tells you to release insulin. When insulin is released, It will then bind to this little receptor, and then the body will make what's called a GLUT4 protein, which is basically just a channel that allows sugar to go into the cell. So when that happens, all this sugar spiking is going to go into the cell. Now the cell is going to use it as energy. And I know there's a lot of stuff I'm talking about here. We're going to get to the easy stuff when we get to the end, okay? So don't get overwhelmed. I'll give you some take-home things that are actually going to make sense. Then what happens is when the insulin is released, that's when the blood sugar is going to start going down. So when insulin gets released, it goes up, and then blood sugar goes down. That's all the steps that happen when you're healthy. And your body regulates this so finely that your blood sugars will stay between 85 and 100. That's your normal blood sugar levels in circulation so that you're healthy. That's the body working correctly. So we eat food, we digest it. Sugar goes through the bowel, is released. Our brainstem and our pancreas recognize that blood sugars are going up. And so they actually release, when they recognize that, they release insulin, which is a hormone that will bind to the receptor, the insulin receptor, which will then make a hole in the cell so that you can suck in sugar. And every single cell does this. And you tell me that God didn't create this. Okay, so that's pretty elaborate, right? That's normal. Where could we have problems? Could we have problems with the brain not perceiving the right amount of blood sugar? Yes. Could we have problems with the receptor site not getting insulin connected to it? Yes. Could we have problems with the proteins not being formed correctly so that sugar can be absorbed? Yes. You can see we can have lots of different problems. And different ways to help it are based on different ways to try to help the different issues. And we'll go through some of the things that we're seeing nowadays of how this can be helped. Do we have any questions on what I just explained? Okay. Okay, no problem. It's going to be online. There's going to be a video. We're going to go over it again, okay? Yeah, we'll go through the difference between number 1 and number 2. All right, so let's look at the brain. If your brain perceives that you could be injured emotionally, physically, or chemically, that means you're not aware of it. Your body will, guess what? Spike blood sugar. How does it do this? Your brain will say, let's make more cortisol. Cortisol will numb you, but it also spikes blood sugars. So if you get a cortisol injection for pain, and you have blood sugar issues, your blood sugar will start going way out of control. So that's like pregnanolone, prednisone, all that stuff that you take. It will mess with your blood sugar levels. It will literally spike them up. So if you're taking a pain med, like a cortisone, it will spike your blood sugars and can cause more issues. That's something you want to be aware of. So the pituitary is causing the hormone to then be released from the adrenals. And then the adrenals will actually move into the pancreas or into the liver, and the liver will actually liberate sugar. It'll let sugar go. So just stressing out will actually cause blood sugars to spike. So you may have noticed this. If you're under a lot of stress, you're like, I got to go. And you're just fight or flight all day. And then you get home, you're like, I'm so tired, and you just fall asleep. It's literally because you're draining all your blood sugar because you're chronically using it. Because when you're in fight or flight, your metabolism goes up. You need more energy to run faster. So that's one way to drive it up. Now, type 1 and type 2 aren't as simple as they can be anymore. So we're going to say autoimmune and inflammatory. Type 1 is what's called autoimmune diabetes. So in type 1 diabetes, what happens is your brain and your body become so fatigued that it misinterprets a protein for being foreign. It's called molecular mimicry for basic sense. What happens is a protein that you eat looks exactly like a protein in your body. The protein that mimics it is casein. And you go, well, what's casein in? It's in dairy. So dairy is directly correlated to type 1 diabetes. So you need to be aware of that. So the casein protein mimics, which means it looks like the same amino acids as the pancreas islets of Langerhans. Then when you're inflamed, your body can go, oh, you drank dairy. That's a foreign body. Let's make antibodies to it, which means it makes it think that it's a virus or a bacteria. And then the body scours around, the B cells do this, scour around antibodies. They find that protein chain again, which is your pancreas, marks it as foreign, and then your immune system attacks it. And then you literally eat your own pancreas away. So you destroy it. So type 1 diabetes is an autoimmune disease where you actually destroy your own pancreas. And as a byproduct of that, you don't make the insulin. So we got pancreas here. You don't make the insulin that's supposed to bind to make that receptor site open. So that's what type 1 diabetes is. So it's literally an autoimmune disease. It means your body has, by accident, interpreted the pancreas as being foreign. That's the same as your body, by accident, has interpreted cartilage as being foreign. That's called arthritis, rheumatoid, or inflammatory arthritis. Or your body, by accident, has made that your skin is foreign. That's called psoriasis or eczema. Or your body, by accident, has decided that your adrenals are foreign. Then you got Sjogren's disease. There's all these different things that can happen, but it's all literally your body is overreacting because it's not communicating correctly and making you attack something. And that's how you get type 1 diabetes. Is it making sense? Yep. Lupus, yep. Systemic lupus, all those things, yep. So any disease where you attack yourself is an autoimmune. There are ways to help people with that. The key is a product we have called Nitric Balance, which actually helps you suppress the product that the body uses to destroy its own cells. So that's type 1. It used to be considered adult onset, but we're actually seeing type 1 in children nowadays because they're so stressed out. So there's no adult onset anymore. There's just autoimmune or stress-induced diabetes. So type 2 is completely different. Type 3 is different as well. That's gestational diabetes. That's when mom's pregnant. But that's because hormones go out of control. And we can explain that one as well. But we'll probably just stick to type 2 because I only got 15 minutes left. So type 2 diabetes is completely different. It has multiple stages that can go wrong. In type 2, the same problem is happening. You're not absorbing sugar. But in type 2, your pancreas works, but it can be A, fatigued, B, the receptor site is clogged, or C, you're not making enough GLUT4 proteins, because you don't have the right nutrients to actually make the amino acids to make the proteins. So you can see there's many causes of type 2. So let's look at one of the causes. Your pancreas is fatiguing. Now, why is this going to happen? What's going to happen is when you eat food and the blood sugar goes up, the pancreas releases insulin. If the blood sugar doesn't come down, it releases more insulin. It releases more insulin. It releases more insulin to try to get you to pull it in. But if these receptor sites are clogged, the insulin doesn't work. So what would clog those receptor sites? Have you guys ever heard of triglycerides? That's what clogs the receptor sites. It clogs the receptor sites for any hormone. That means if you have a thyroid problem and you have high triglycerides, your thyroid will never work correctly. If you have a adrenal problem and you have high triglycerides, adrenal issues aren't going to ever get resolved. If you have a blood sugar problem and high triglycerides, your blood sugar will never resolve until you get your triglycerides down. So how do we actually make it to get better? Well, a lot of people go, well, why are my triglycerides there anyways? What's going on? Why are they high? Triglycerides go up for one specific reason. When you eat food and your blood sugar spikes and your insulin receptors aren't working correctly, your body needs the sugar. It doesn't want you to lose it. So what does it do? It says, well, if we can't absorb it, we don't want you to pee it out. So we want to save it. We're going to save it as fat. So what it does is it sends the sugar to your liver and then converts the sugar to triglycerides. So that sounds smart, but that's how you get non-alcoholic fatty liver, is you have a blood sugar issue and you're not actually healing it because you're taking all the sugar in, and your liver, instead of detoxifying you, is trying to take the sugar and turn it into fat. Does it make sense? So triglycerides high will not work correctly. Another thing that will stop you from absorbing the sugar correctly. So we got our cell, we got our receptor site, we got our GLUT4 protein that allows sugar to come in. We got sugar all over the place. It's supposed to come in the cell. If your sugars stay high for a long time, they will attach to different proteins. You ever wondered what hemoglobin A1C means? It's oxidized sugar to hemoglobin, which is red blood cells. So it's sugar attached to a red blood cell because it's been in the system too high for too long. That's what hemoglobin A1C is. It's just telling us a chronic high sugar level and inflammation. But what will happen is if your blood sugars stay too high for too long, they'll attach to proteins that are going through the bloodstream, and that's called glycation. And what that means is you'll have these sugar protein molecules that bind here and don't make that protein open. So high triglycerides, sugar protein molecules, clogging up that site. Oh my gosh, doc, what am I going to do? My lipids are always high. My triglycerides are always high. Well, God gave us an answer. It's in fish. It's in beef. And the answer is omega-3 fatty acids. Omega-3 fatty acids come in and knock anything on there off. It'll knock triglycerides off. It'll knock glycated proteins off. It will actually open up the receptor site. So if you have diabetes and you're not on omega-3s, I'm sorry to tell you, you're doing it wrong. If you have diabetes, you need to be taking 3 to 4 grams of omega-3s a day. Not pill size, grams of the active ingredient. So what's the active ingredient? DHA, EPA. That has to add up to 3,000 to 4,000 milligrams a day. If you do this, we have literally watched people's blood sugars drop into the normal range and their A1C go to normal in 3 to 6 months. If it's simple and it's not working right here. I'm sure you've heard of these ads, Ozempic and these different, they're called GL1 receptors or GLP-1. And what it is that's a hormone that makes your pancreas produce more insulin. So like Ozempic or other drugs like that, what are GLP-1s, they actually force your pancreas to push out more insulin. But if your receptor site is clogged, it's not going to help you. Make sense? So if your lipid panel is high, you can take Ozempic, it'll drive it out, but eventually you're going to burn out your pancreas. Mm-hmm. So why you would lose weight is you gain weight. The question was, why would you lose weight if you took Ozempic? When you have more insulin in your bloodstream, you will pull more sugar out. Then what your body needs to do is create more sugar. So it will metabolize fat through the Krebs cycle and it pushes it out to have more sugar. So you're overusing the sugar in the system and your body balances out by turning fat into sugar. Does that make sense? So that's how that works. For short periods of time, it's fine, but the long period studies are not good because you can fatigue your pancreas. So just think of your pancreas is supposed to turn on and off, not turn on and run hard at 100%, and then eventually you'll start fatiguing those cells, the islet cells. So we don't want to continually do it. For short-term intervals, it is good for you if you need an acute help, but not long-term. So the other things that we can look at are things that will help these receptor sites become more active. And those things are actually herbs that we can give you. Validium, chromium, ALA, magnesium. Those will actually increase the production of the GLUT4 proteins, which allow you to actually absorb the sugar in. And don't worry, I have supplements that literally have all this stuff in it. So you don't have to go buy each individual one because that would get really expensive. The other things that actually help the receptor site become more active are ALA, chromium, biotin, vanadium, berberine, rose hips, short chain fatty acids, exercise, burdock root, and fasting. So you go, okay, well, what do I take, doc, if I have type 2 diabetes? You take a product that we have called glycoberine, and you take a product we have called glycine. Those products help with receptors and receivers. The product berberine is so powerful in making the receptor work through another pathway called the AMPK pathway, that if hospitals run out of insulin, they will actually give them 15 to 2,000 milligrams of berberine, and they'll have the same response as insulin. So do you hear what I said? There's something that isn't a drug that'll make your insulin receptors work better. And that's been scientifically proven. So what I'm showing you here is that your body can heal itself if these things are working correctly. As long as the receptor site works correctly, it'll work. So what do we need to take to make sure the receptor site works correctly? Omega-3s. We need fish oil. Fish oil is literally the thing that'll make all the hormones work correctly. You got a friend with PCOS, fish oil. You literally, I don't know if you ever watched the Big Fat Greek Wedding where the guy said Windex for everything. You got a problem, put Windex on it. You guys know what I'm talking about? Yeah. If you don't, it's basically saying if you have any problem, put Windex on it. If you have a problem, take fish oil. It's anti-inflammatory, makes all your hormones work correctly. Will literally rebuild the cells. You just got to take a lot of it. You need to take that 2 to 4 grams a day. And it will literally make your cholesterol come down. It will literally make your hormones start working correctly. It'll make you become insulin sensitive. It'll make you heal. Before we became industrialized, we were eating lots of products that were high in omega-3s. You say your chief Arapaho, he was eating buffalo that was high in omega-3s. The tribes up in the Northwest, they were eating salmon that were high in omega-3s. When the people first came over, they noticed that they had bright eyes, really bright teeth, and it's because they had lots of omega-3s, and they were eating all their vitamin A, D, E, and K, all their fat soluble vitamins. The problem with our country nowadays is we're not getting those fat soluble vitamins. 99% of everybody I meet is vitamin D deficient. Vitamin D literally turns on a third of every gene you have. That means if you're vitamin D deficient, 1/3 of everything that happens in your body is not going to work correctly. It's directly correlated to depression, anxiety, cancer, diabetes, all these other things. So omega-3s are really good. Vitamin A, D, E, and K, really good for you. Will keep you healthy. So as you can see, there's lots of different things that can happen here. If you're stressed out, it can cause diabetes. If you have deficiencies, it can cause diabetes. If you have too much triglycerides, which can happen from eating the wrong foods, inflammatory foods, anything out of a box, or chronically being stressed, diabetes. So think of your friends and family members who have uncontrolled blood sugar, just get them on fish oil and you will literally change their lives. Then if they need a little more help, we can do lab testing. We can see what is their A1C, what is their glucose levels, are their kidneys working? There's other stuff we can test. And then we can look at what do we want to do? Do we want to help the receptors be more receptive? Do we want to make sure the protein channels open up? Or do we want to use all of them at the same time? And so it's not as simple as take insulin. If you have high triglycerides and you take insulin, it's not going to work the way you want it to be. That's why they put them on various different forms of insulin. So if you have a friend or family member who has diabetes, type 2, we can definitely help them. Type 1, we can help them get things under control. We have one lady right now we're taking care of, and when she started care, her blood sugars were averaging between 300 to 400. And now she's around 120 to 140. And she's not a small lady. The bigger you are, the more inflammation you will have. But that has literally changed her life. And she was a type 2, I believe. Type 1 is harder, but with the supplementation and proper use, you can actually watch the body start controlling it. Do we have any questions? Because type 1 is autoimmune, so you actually have to help regulate blood sugar as well as help the immune system not attack the pancreas. So think of your friends and family members, and if they're sick and tired of doing what they have to do, taking the drug, pricking their finger, whatever it is, let them know maybe we should get it checked out and see if there's something else we can do for you. So I want to thank you all for being here. Talk to your friends, help them out, and have a blessed night.
Awesome.
Answer all your questions.